Welcome to this lecture on the implantation of the blastocyst and early embryonic development. By the end of this session, you'll understand the step-by-step process of implantation, the formation of the bilaminar embryonic disc, and the early development of extra-embryonic structures. Let's dive into the details. Let's start with the 7-day-old blastocyst. At this stage, the blastocyst is preparing for implantation. The outer layer of the blastocyst is the trophoblast, which will later differentiate into two layers, the syncytio trophoblast, a multinucleated layer that invades the uterine wall, and the cytotrophoblast, a cellular layer that supports this invasion. Inside the blastocyst we see the epiblast and hypoblast, which form the bilaminar embryonic disc. These two layers are critical for the embryo's development. By day 8, the blastocyst attaches to the uterine lining, initiating the process of implantation. The trophoblast begins to invade the uterine tissue, with the syncytio trophoblast producing enzymes that break down the maternal epithelium. Meanwhile, the amniotic cavity appears within the epiblast. This will eventually surround the embryo, providing protection throughout development. The hypoblast begins to spread to form the primary yolk sac, which plays an important role in early nutrient transfer. By day 9, the blastocyst is further embedded in the uterine lining. The syncytio trophoblast continues to expand and starts producing human chorionic gonadotropin, or HCG. This hormone signals the corpus luteum in the ovary to maintain the uterine lining, ensuring the pregnancy is sustained. At this stage, the primary yolk sac is well formed, and we can also observe the development of the extra-embryonic mesoderm, which will later contribute to the chorionic structures. By day 12, spaces called trophoblastic lacunae appear in the syncytio trophoblast. These lacunae eventually connect with maternal blood vessels, establishing the early uteroplacental circulation system. Simultaneously, the extra-embryonic coelom, also known as the chorionic cavity, begins to form around the developing embryo. This cavity will surround the amniotic sac and yolk sac, providing structural support and space for further development. By day 13, the chorionic cavity is well developed, and the primary chorionic villi begin to form from the cytotrophoblast. These villi invade the maternal tissues and are essential for the formation of the placenta, which will support the embryo throughout pregnancy. In the center we see the bilaminar embryonic disc, with the epiblast giving rise to the embryo itself, and the hypoblast contributing to extra-embryonic tissues. The connecting stalk, which later becomes the umbilical cord, anchors the embryo to the chorionic structures. To summarize, implantation begins around day 7, with the trophoblast initiating invasion into the uterine wall. By day 12, the uteroplacental circulation is established, and the chorionic cavity forms. By day 13, primary chorionic villi develop, laying the groundwork for the placenta. Clinically, the production of HCG by the syncytio trophoblast serves as an early indicator of pregnancy and is the hormone detected in pregnancy tests. Understanding these early stages is crucial, as abnormalities in implantation or early development can lead to pregnancy complications such as ectopic pregnancy or miscarriage. This concludes our lecture on implantation and early embryonic development. Thank you for your attention and see you in the next session.